Okay, this is Math 105, section 1.2. We're going to talk about exponents first. Integer exponents, when we talk about integers, were numbers without decimals, positive, negative, or zero. So when we take a number, any real number, and we take it to the nth power, that means we're multiplying that number n times. Okay, for example, so a is called the base, and n is called the exponent. So n is the number of times that you're multiplying, and a is the number that you're multiplying. So I'll use the example above that didn't print out right, but we can say 5 to the third equals 5 times 5 times 5. We're multiplying 5 3 times. You notice that 3 there, okay, is our exponent. Okay, and that's how many times we're multiplying. So 5 times 5 times 5 is 125. Okay. Here's some quick examples. Here we have our base is 1/2, so that's we call that a rational base, but it's a ratio of integers. And we have 1/2 to the fifth, which means we're multiplying 1/2 5 times, okay, which is 1/32. Okay. Let me rewrite this one because it didn't come out quite right. Okay, so this should be -3 to the fourth. Okay. Okay. So what we're doing there is pay attention to the parentheses, because we're multiplying what's in the parentheses 4 times. So that's -3 times -3 times -3 times -3, which is going to be, now we're multiplying 4 negatives, so that would be a positive answer, and that would be positive 81. Okay. This bottom one, see, let me scratch that there. Okay. Bottom one is -3 to the fourth. Now notice we don't have parentheses there, okay? So we're not really multiplying -3 4 times. What we're multiplying 4 times is just that 3 there, okay? So this is actually -1 times 3 to the fourth, which is -1 times 3 times 3 times 3 times 3, which gives us that -81, okay? So be careful with that. When you don't have parentheses in your base, you can only use one character. Okay, so the rule of thumb for exponents, when we have parentheses, we would multiply what's in the parentheses. But if there's no parentheses, we just use one character for the base only. Okay, so in this case, when you do have parentheses, -3 parentheses squared is -3 times -3. Notice for multiplication, we don't put x because we're going to use x as a variable. So sometimes you'll see the dots there. Sometimes you'll just see them next to each other, which means we're multiplying. Okay. When we don't have parentheses, -3 squared, we can only use this one character as our base, which is the 3. Okay. So it would be -1 times 3 squared, or 3 times 3. So that would give us -9. And that's true for variables as well. So let's say I have -x parentheses squared. That's going to be -x times -x, which is actually a +x squared. Okay. But if I just have -x squared without parentheses, what I'm really doing there is -1 times x times x squared, or times x times x. Okay. So my base is just the x there because we don't have parentheses. Okay. So this is actually going to be -x squared, right? Okay. So notice the difference there. Okay. This is not going to have a minus in front of it because we're multiplying a negative times a negative. But here we're not. We're actually taking -1 times x times x. Okay, when you take something to the 0 power, it's always 1. Okay, so we're not going to take 0 to the 0 power, but when a is not 0 and it's a real number, we take it to the 0 power, we get 1. So any number to the 0 power is 1, basically. Okay. When we take a negative exponent, what we're doing is taking 1 over a to the positive exponent. Okay, think of that as, we're not multiplying n times, but we're dividing n times with a negative in your exponent. Doesn't mean you have a negative number, it just means you're dividing instead of multiplying. So here's some examples. 4/7 is our base, to the 0 power is 1. Okay. X to the -1 is 1 over x to the +1, which is 1 over x. Now here our base is negative, but we're also taking to a negative exponent. So let's keep that negative base, but we're going to say 1 over -2 to the +3. Okay. And we have -2 to the -3. And then we can evaluate that -2 cubed, which is -8. Remember, we're multiplying -2 3 times here, so that's how we get to -8. And generally, when you're doing negatives, put your negative either in front of the fraction or in the numerator. Don't put it in the denominator. So this is bad form here. Don't leave it in this form. Okay. Put it either negative in front of the fraction or in the numerator. Okay, so this is listing our laws of exponents. We'll look at examples of these, but when you're multiplying two exponents with the same base, you add your exponents and keep the base the same. So 3 squared times 3 to the 5th was just 3 times 3 to the 2 plus 5, or 3 to the 7th. Okay. If you're dividing with the same base, you're going to subtract those exponents. So a to the m over a to the n is a to the m minus n, or in this case 3 to the 5th over 3 squared is 3 to the 5 minus 2, or 3 cubed. Okay. Try not to confuse law 3 with law 1. Law 1, we're multiplying two exponents with the same base. Law 3, we're taking an exponent to another exponent, and here is where you would multiply the exponents. So a to the m to the nth power is a to the m times n, okay? Or we can say 3 squared to the 5th is 3 to the 2 times 5, which is 3 to the 10. Think of what we're doing here. We're multiplying 3 squared 5 times, right? So you're going to add that 2 5 times when you multiply these. So that's why you get the 10, 2 times 5. Okay. When you're multiplying inside your base to a power, we can take that those two parts of the base out and say a to the n times b to the n. So 3 times 4 squared is 3 squared times 4 squared. When you're dividing, you can break them out as well in your base. So a over b to the n is a to the n over b to the n, or 3, our example here is 3 4 squared is 3 squared over 4 squared, or 9/16. Here's what you want to avoid. These are not laws of exponents. Okay, so a plus b to the n is not equal to a to the n plus b to the n. Okay, so be careful with that. And then we can say also a minus b to the n is not equal to a to the n minus b to the n. So be very careful with those. When you're adding or subtracting inside a base, you cannot break out the exponent. Okay, that's a real easy mistake to make. Don't confuse it with the 4 and 5 here, where you're multiplying and dividing. You can do that. When you're adding and subtracting, you cannot. We'll look at examples in class why that's true. Okay, here's an example using variables, but we have x over y cubed times y squared x over z to the 4th. And what we're going to do is we're going to give x and y that third power based on our laws when we're dividing, okay, in the base. And then we're going to give y squared that 4th power. We're going to give x that 4th power. And we're going to give z that 4th power in the denominator. Okay, and then this becomes y to the 8th. So we're using laws 4 and 5 here. Okay, and then that gives us this, x cubed over y cubed times y to the 8th times x to the 4th over z to the 4th. Okay, and then we're kind of putting things together. Now notice how we're regrouping here. We're using our property, our associative property. We're saying when you're multiplying a bunch of things, okay, you can rearrange them. So we're going to put the x's together. Okay, the x cubed and the x to the 4th. We're going to put the y's together, the y to the 8th divided by y cubed, and we're going to put the z's together. There's only one z, but we say 1 over z to the 4th. Okay, so what we're doing here is rearranging things so all the x's are grouped, the y's are grouped, and the z's are grouped. And then we can use our laws 1 and 2 of exponents to say, okay, x cubed times x to the 4th is x to the 7th, y to the 8th over y cubed is y to the 5th, and then 1 over z to the 4th is just 1 over z to the 4th. So there's our answer in simplified form. Here's some additional laws of exponents. When we're dividing in our base and we're taking to a negative exponent, we can just flip that fraction, take the reciprocal, and take it to the positive power. Okay, positive n here. So 3/4 to the minus 2 is the same as 4/3 to the plus 2. Okay, and then 7 is kind of similar. We have a to the minus n over b to the minus m. We can move the a to the denominator with a plus n power, and we can move the b to the numerator with a plus m power. So when you have a negative exponent, what you can do is move your exponent to the other side of the fraction with a positive. So this goes up to the numerator with a positive m, and this a to the minus n goes down to the denominator with an a to the plus n. Okay, so 3 to the minus 2 over 4 to the minus 5 is the same as 4 to the plus 5 over 3 to the plus 2. Okay, let's look at a couple examples. Let's look at this one first. We're going to simplify this one. 6st to the minus 4th over 2s to the minus 2t squared. Okay, so what we're going to do is put the s's together, okay? And what we can do is we could take that s to the minus 2 and put it as s to the plus 2 in the numerator. And we could take that t to the minus 4 and put it as t to the plus 4 in the denominator by law 7 of exponents. And then we're just going to combine the s's. This would be s cubed. This would be t to the 6th. And then 6 over 2 is 3. So that gives us 3s cubed over t to the 6th. We don't want to leave negative exponents in our answer. And then b, we're taking y over 3z cubed to the minus 2. Now we can immediately flip this fraction and take it to the plus 2. It makes it a lot easier because we don't have to deal with so many negatives. So we have 3z cubed over y to the plus 2. Now that's going to give us 3 squared. Okay. Z cubed squared, which is z to the 6th, and then make sure we take every part of this gets the square, so y squared as well in the denominator. So their answer is 9z to the 6th over y squared.